Hello everyone. So in today's video, we'll learn about dependency inversion principle. The name itself seems to be very scary. And let me be very honest with you here. I wasn't able to understand it for quite some time. I watched many videos, read from multiple books and practiced a bit. And then only I got what it means and why do we even use it. So let me take this opportunity to explain it to you. So as always, let's start with the definition. What does dependency inversion principle say? It says all components or classes should depend on abstractions and not on concrete classes. This makes the code much more flexible and decoupled. Now, if you have dependencies in a class, it better be an abstract class. Otherwise, you will get into trouble. If you're wondering what dependencies are, why should I depend on only abstract classes and all those questions? Just give me 5 to 7 minutes and I'll explain you all these things using an example. So let me take a moment to go over this repository which has numerous classes here. We have a vehicle class or an abstract class which has some initialization and a method or an abstract method called as insurance, calculate insurance cost. We have other abstract classes such as fuelable, which has only one method refuel, and rechargeable, which only has one abstract method called as recharge. And we have numerous classes like car, truck, electric car, which implement all of these methods. Taking from vehicle, fuelable for the car. Similarly, for truck, we have vehicle and fuelable, and we are implementing calculate insurance cost and refuel. And very similarly, we can look at electric car, and we have the insurance calculator class here, which just has calculate vehicle insurance. And we are testing all of this in our main here. So let me just run this once to see if everything is working perfectly. Okay, it looks to be correct. I can see no errors here. So let's just move on now. Now, after implementing all of those things and checking that everything works correctly, let's go ahead and create one more class. Let me move it here. Let me call a new file. Let's call it brake inspection tool, or rather, I should probably have brake inspection tool. That looks correct. And for that, I'll just simply take from vehicle, I think I missed on the spelling there. Let's have that. And let's implement this class. Brake inspection tool. I don't need initialization. I just need one method here, which is for performing a brake inspection. Let's see. Okay, that looks correct. And for this, I'll have, let's say, perform brake inspection on let's say a vehicle, which is vehicle.make and vehicle.model, and we'll keep it this way and no need to format it. Oh, I think I should probably format it. Okay. And similarly, we'll also have another class called as maintenance service. So let's just go ahead and create one. So I'll say that as maintenance service, and I'll have taking it from brake. That is correct. Import brake inspection from vehicle. Import vehicle. That looks correct. And let's say class maintenance service, and then I'll have some kind of initialization, and let's call it self.brake. That looks correct. And similarly, I'll have one more method here. Let's call it service vehicle and self.brake inspection tool. I'll rather talk about not having brake inspection tool, but self.tool, and I'll use that here. and perform brake inspection. Yeah, that looks correct to me now. Now if I go ahead into main and try to test it out, let me just go ahead and add, and before that I'll need to import it first from the maintenance service, import maintenance service. That looks correct. Now let me add a code here for the maintenance service, and then I'll simply call service, or let's call this maintenance service as service, and then I'll do service dot service vehicle as car. Okay. So let me just go ahead and run this. Let me move it here so that it's in the end and it's visible. So let me go ahead and run this. Okay, performing brake inspection on Toyota Camry, that looks correct. Now until now everything looks correct. But if you see our maintenance service is directly dependent on brake inspection tool. The dependency here for maintenance service is brake inspection tool. So let's say somebody comes up and suggests, instead of having brake inspection tool, let's have tire rotation tool. So I'll go ahead and let's say I do it tire rotation tool. So in order to do that, I'll have to make changes here. I'll also have to make some changes here. But that doesn't sound very bad, right? But here, if you notice, we are breaking open-close principle. How so? We are modifying our existing class's method and not adding a new class and using that to add a new feature. So we are breaking open-close principle. So what are the consequences for it? So all the classes where this maintenance service is used and service vehicle is called, we will have to go into each of those classes and check if everything is working expected or not. So let me rephrase it. Let's say I have a class which uses maintenance service. Or let's say there are 10 classes where maintenance service is used. And in all those 10 classes, I am calling maintenance class dot service vehicle. In all those classes, I'll have to go ahead and check if this new definition with car rotation tool is making sense or not. That would be a very big hassle, because if you see, this is a very small repository. If we have a very huge code base, that would be very problematic. So now we have run into a situation. So how to fix this? Let's go to our definition of dependency inversion. All components should depend on abstractions and not on concrete classes. So here our maintenance service was dependent on brake inspection tool, which is a concrete class and not an abstract class. So we'll fix that. So let's just go ahead and create one more abstract class. Let's just go ahead and call it maintenance tool. Okay, so from this, what I'll try to do here is I'll create it as an abstract class. Import ABC, and from vehicle, I will have vehicle. Now, let me define this class, and I'll have an abstract method of perform, let's say, maintenance. That should do. Here, if you see, I have created a generic method called as perform maintenance, and it is taking an input as vehicle. Now, what I'll do here is that I'll use this abstract class inside brake inspection tool. I'll go ahead and import from maintenance service, import maintenance service, and then I'll basically inherit from that. That looks correct. And I'll need to change this to perform maintenance. That looks correct. And it is taking vehicle as input. And I can have any print statement here. I can say perform brake inspection on vehicle.make vehicle.model. So that looks correct now. Now once we have that abstract class ready, and also make changes into this brake inspection tool, now we can go ahead inside the maintenance service and use that abstract class, that is maintenance tool. So let's just go ahead and remove this from maintenance tool, import not brake inspection tool, but rather maintenance tool. That looks correct. And now let's use this maintenance tool in place of brake inspection tool. So let me just get rid of this, and we'll pass on this as tool and maintenance tool, and then we'll use it. Why am I using that as input or in the initialization for maintenance service? I'll talk in just a bit. So let me just make changes to this, and instead of performing brake inspection, I'll need to change this to perform maintenance. That's correct now. So after that change, let's go ahead and make changes to our main method and test it out. So here we have the main. I'll probably need to import from brake inspection tool, import brake inspection tool, and I'll need to pass it on to the maintenance service. So I'll do the brake inspection tool, and let me just go ahead and run this. Oops, I see an error here. It's in brake inspection tool, and I think I know it. I think we are taking inheritance from maintenance service instead of maintenance tool. So I'll just change that, and let me just copy this here, and that should probably fix it. So let me just go ahead and run this again, and everything looks perfect again. So performing brake inspection on Toyota Camry. Now let's go ahead and talk about why we have any kind of tool like brake inspection tool here as a parameter in maintenance service. Like as you can see, we have a tool, maintenance tool as a parameter. Why did we even choose this kind of design? This is mainly because let's say we have another tool, or we want to change this tool here from brake inspection tool to, let's say, tire rotation tool. So I can simply go ahead and then replace this. Let's say I'll do tire rotation tool, and obviously I'll create a class for that, very similar to brake inspection tool. But you see the convenience here. We just have to make changes here and good to go. We do not have to go inside the maintenance service to make any kind of changes there. If we would have to make changes to an existing class and a method, that would break open-close principle, and we do not want that. So that is why we have the design of passing in the brake inspection tool or any kind of tool inside the maintenance service. This is also called as dependency injection, where we are injecting a tool or a tool, brake inspection tool or anything inside maintenance service. Now let's talk about what happens if we do not follow the dependency inversion principle. So let's just go ahead and understand that. So the first thing, what happens if we don't follow the dependency inversion? Let me just go ahead and change this. Yeah, what happens? So we will break the open-close principle. As we saw, we will need to modify the existing methods. And if we do that, there's a high chance you might introduce bugs when modifying existing classes. So as you could see in the previous implementation, if we made changes to here, if we made any changes to our maintenance service class, our previous one, then we would have to go inside each of the other classes which uses maintenance service and check if the new implementation made sense or not. Like let's say we had, earlier we didn't had this, we had our tool as brake inspection tool here. So let's say if I change it to tire rotation tool, I'll have to go inside each of the classes which use maintenance service and then check if this new implementation with the tire rotation service is making sense to that or not. Yes. So hope that makes sense now. So that's what happens if we don't follow dependency inversion principle. But what are some thumb rules that you should remember at the end of this lecture? The first thing is always have abstract classes or interfaces as dependencies. Try not to have dependencies on concrete classes. Here you can see that we have dependencies on maintenance tool. The maintenance service has dependency on maintenance tool here. And maintenance tool is an abstract class, not a concrete implementation. So you want such a design which depends on such a class where it depends on other abstract classes or interfaces. The second one is always try to pass dependencies into the class when initializing. So as you can see, we are passing in the brake inspection tool to maintenance service. That kind of design we want, because in the case where you want to change the tool, let's say I want to change the brake inspection tool to tire rotation, I can freely do that. So we have some kind of flexibility. So those are the two thumb rules that you should remember at the end of this lecture.